So for the spatial function, SciPy have different output. For this, we have put have SciPy dot right spatial library here. Py one dot here I'm having right. So you can see it's getting 1 to 100, right? So this 1 to 100 part is just sequence number from 1 to 10 only, right? So can we have this IPy dot L dot CRT dot of my the entire number? Can you see the entire value is of and sequence 1 to 10. Focus at the 8 value of 8 is 2. I how is 2? Because you check this point 2 raised to power 3 8 8. So vice versa of this is possible. 8 raised to the power not but not the square root but cube. So as far as cube of 8 is in a reverse order it so finally we are getting here, right? Let me give some another example. Let equal to np dot range some number inside the array uh, is 12 21, right? And for this I'm try scipy dot spatial function rt root, so cube root of all the elements of b. Oh, our value, can you see this cube root of this first 12, right? Cube root of 13 14, right? We will multiply this value 3 times. Can you check it? Yes, we can check. Multiply this value by the last value 3 times. So you will get almost 20. Can you see? It's a 20.000 something 5, almost approaching 20. Because we are excluding the last value in the range, all the terms here, right? Can perform the same. If you want to get exponent of 10, so how to perform exponent of? We have exponent of 10, and then we get the exponent of like exp 10 of any polynomial. I'll assign some x is then SciPy function spatial function dot 10 10. Can you see giving 10,000, right? So exponential of 10 means 10 raised to power something, right? If you write 5, will get of x is 10 raised to power 5, which is 1 lakh something, right? So this is the exponential of 10. Suppose we need exponential of something else, right? Suppose exponential of 2, right? This of 2. So we have exp then 2 raised to power 5. So of course it is 32. So you can see, you can find out the exponential of 2 by just importing exponent. And can you raised to power 10 is 102. Right, the right raised to power 10 1 4. It's like this. So this term is actually called exponential of the experience. Right? Do we have another exponential? Let's check it out. Instead of we have exponential of, let's say, 3. Cross check, have 3, have 3. Right? Do we have exponential of e? Have exponential. So now the next part is degree of radian. Right? What is degree of radian? So the function for this equation, and we pass just d comma m comma s. Right? These parameters have to pass. So first let me create d is equal to 30, then m is equal to 10. Right? For SciPy dot dot radian would be d comma m comma s. Right? So this is kind of this. You can see from here also find some another part. So find out SciPy spatial rate code appear to be attempting calculating, and we have radian. Right? Have degree, have part function calculating this angle in degrees. Right? So d stands for, m stands for minutes and second respective form. Right? So if you'll pass the values of m and s, it's can we calculate the trigonometry function for the same trigonometric function degree? Right? Have kind of, right, sine of psi pi dot dot sine in right with 30. Right? Actually, second function we have cos of 30 degree. Right? Sine pi dot spatial, then we will have c cos of degree. Actually, we are having 10 of 30 degree, have spatial 30 degree. So you will find it's almost 0.5. Have 30 degree for the for cos 30 degree, have cos upon, so this will cos 30, 10 of 30 degree, have 1 upon calculate this. So we have root value up around 1 upon 1 points almost, and this value, right? Tangent of 30 degrees, right? So can we find out the permutation combination this SciPy library? Yes, inside the SciPy library have space, and this called permutation, right? The permutation 5 comma, right, 5 comma is just 20 for the conventional formula. For this convention have 5p, right? 5p, what, 5 factorial upon 2 factorial, right? So this is 5 factorial, value of 5 factorial. Here we have 5, have 4, have 3, then factorial, right? Denominator we have 2 factorial cut by factorial by 2. So we have 5 for the 20, and then, right? So 3 have, oh, this 5p equal to 5 factorial upon factorial, right? 5, so factorial divide by factorial, then this factorial cut by have numerator any value at the have 20, 20 is, right? Can we the combination be, yes, we can use combination. X is scipy dot space dot combination, and this will 5 seed, and this is how it is, have 5 formula for 5 seed have equal to factorial, factorial. Expand this denominator have 2 factorial. This 3 cut by this factorial from, and this cut by from. Finally, 5 into 10. The output of 5C have combination. Right? Now, the next part is the dictionary.